How's it going? My name is Scott Moss. I'm a senior engineer at Netflix, and this is a course about AI agents. I create this course not only because I'm excited about AI agents, but also because it's a core skill that I think every software engineer is going to need in the future. In this course, we're going to learn the capabilities of AI agents, and then we're going to reel it into something more practical, where you're going to learn how to build an agent loop from scratch, evals to improve your agent, tool calling, approvals, and even something advanced like compaction. Go and build AI agents that can even surprise you in what they can do. So the first time I ran an LLM API, I was blown away. I was just like, I don't know, I feel like I had a wand in my hand and there was like somebody on the other line that, it was like a genie, right? But like this genie kind of sucks because like I can't really ask it to do anything past its training cutoff date, right? Because the way models work is that they're trained up to information on a certain date. And by the time you get access to the model, that training cutoff date was probably almost a year ago because there's like tons of checks for safety. So if I ask this thing like, what is the, or if I ask it like, who won the NBA or the 2025 NBA finals? If this thing wasn't trained after that event, it's either gonna lie or it's gonna say, I don't know, right? So I'm gonna run this again and we can see what it comes up with. So it's thinking really hard now. And it says, did you mean who won? And it says who will. Oh, there it is. I should also note my training only goes to June 2024. So I don't have confirmed 2025 results. I can help make a prediction. So as you can see, it's really not that useful. How do we make it useful? Well, we have to give it the ability to interact with its environment. And the way that we do that is with something called tool calling. So let's hop into tool calling. What is tool calling? Well, it's the mechanism that allows LLMs to interact with the outside world. And we're gonna learn how to do that because if you know how to make functions and you know how to describe what those functions do, like you would normally write comments above your functions, then guess what? You know how to make tools. That's it. That's mostly what a tool is. There are different types of tool calling. The one that we'll be doing is called function calling. Function calling, and they're used interchangeably. So I guess when you hear them both, they both mean the same thing. But function calling just means a type of tool calling where the tool that's being called is a custom function on your system. It's a function that you wrote. There are other types of tool calling in which the execution happens on another system, like an API or on the provider side or somewhere else. But function calling just means you wrote the functions running on your system, and that's what's happening. How does it work? Well, you define the tool. It's a combination of like, a description of what this thing is supposed to do and when the LLM should use it and maybe what it returns. You can give it, you can describe the inputs of that function and as a schema, and the agent, depending on the model that you're using and the SDK that you're using, will abide to that schema when it passes in those arguments. So we get guaranteed contract, here's what you're gonna get to this function, right? And then the third thing at minimum usually is the execute function. So this is the actual function that gets called when this tool gets selected. So what happens is when you give a model a set of tools with those descriptions, and then you prompt the model with some requests like we just did, the model will then see that it has access to these tools by reading those descriptions. And then based off those descriptions, it'll be like, you know what? I could probably use this tool to get closer to answering this question. So I'm going to go ahead and use that tool. But the model itself doesn't actually run the function, doesn't run the code. It's not going to take your function and put it on OpenAI server and run it. Like that wouldn't even work that way. You're not going to serialize a function as a string and go eval it on some server. So what the LLM does, it returns back an object that says, hey, here's an object. This object describes the tool that I need you to call. You said that I have access to this tool, and you said that I have to give you these parameters if I want to call it. Well, here you go. I'm telling you, I want to run this tool, and here are the parameters that I need you to do. Can you go do that for me and give me the results? And that's what we need to do, right? So we wait until the agent says, hey, I want to run this tool. Can you go do it? Here are the arguments. And then we'll do it. We'll execute that tool. We'll grab the results from it, and we'll feed it back to the LLM so it can see it. And then once the LLM sees it, it'll decide what to do next, right? And that's the loop. It'll keep doing that until it's like, oh yeah, I have enough to answer, or I gave up, or some other thing. But either way, that is the whole point of just observing, thinking, and then eventually reaching a conclusion. So type text. Does that mean that the result of every tool call, function call that you do have to be a string? Yes, it does. Does that mean it has to be human language? No. You can put a JSON object here. JSON is a string. It just has to be a string. Everything you return to the LLM has to be a string. So remember that. Okay, so then the last thing we want to do outside of the loop, because the loop is done now. So like, let's revisit that. So as you can see, we don't have a break case in here, right? So once we push these tool call IDs, we hit the end of our loop, it's just going to loop again, right? It's going to go all the way back up. It's going to loop again. It's going to call stream text again. But what has changed since the last time we looped? Anybody know? There's only one thing that's changed.
Well, messages array.
The messages array, exactly. The messages array has changed. And that is the conversation in the LLM's eyes. So all we have to do is just keep appending to the messages array, keep manipulating the messages array, and allow the loop to continue. And we'll either A, hit an error that we throw or break on, B, hit a finish reason that is not tool call, as in I'm done, or C, the AI wants to run some more tools. And that continues the loop. That's it. And then from there, we just want to update the UI to like, hey, I am done. Here's the full response. And then we would just want to return all the messages here. So to get this to run, first, make sure, I'm just going to do an npm install here to make sure nothing's broken. You need to do an npm run build. You might get some TypeScript errors. If you do, just go put any on all that stuff, call it a day. Once you build it, because it is a CLI that needs to run on your machine, you just need to install it locally. So you can do, make this bigger, sorry. You do npm install -g, which installs it globally. So you can just do that. Once it's installed globally, the command is just AGI. All right. So then I can just say hello, and it streams back, right? And now what we can do is we can try to test its memory. So let's run through to see if it remembers stuff, because if we're doing it right, we're appending to the messages array every single time. So whatever context is in that array, it should be able to reference in this conversation. Now, if you close this and start it up, this isn't persisting to like a file somewhere. So like it'll forget, right? We're just putting everything in the messages array. There's no persistence here, but as long as we have it open. So if I say, actually, let's just start over from scratch just so you can see everything. So if I say my name is Scott, nice to meet you, Scott. So it definitely saw that initial message. And then if I say, what is my name? Your name is Scott. Okay. It's correct in our implementation of appending to that messages array. The next thing we want to do is we want to test tool calling. So we have, at this point, you probably only have one tool unless you went and made some more, which is like the get date time. So that's pretty much the only tool that we have. So let's see how that works. In fact, I can ask us like, what tools do you have? Let's see what it says. I have 2 callable tools available. Functions.getDateTime, multi-tool-use.parallel. I'm guessing that's something AI SDK injects and put something in there. What is the current date and time? As you can see, like it's like blink. I spelled time wrong. It'll figure it out. You can see it's called a get date time. It thought some more. It passed it back in, and it said, "There you go, Scott. The current date time is this."
This is really cool.
Oh, I think so. I think it's really cool too, right? It's like you just built a chat thing right in your terminals. It's like really impressive. I like it. It's pretty magical to me.
Yeah, I've seen Chat GPT. I've seen chat agents, and I don't know why this feels so much more impressive, but it feels
because
really
you did
cool.
it. Because you wrote the code. That's why. You understand it now. That's why it's more impressive. How do we implement this compaction? We use a simple compaction strategy. We estimate the token usage before each turn. If over a threshold, we can pick a number, we'll say 80% of the context window, we trigger compaction. We then summarize the conversation history into a condensed form. We replace history with summary, and then we continue the conversation, okay? This isn't the most sophisticated approach, but it's reliable and easy to understand. So let's do it. First, let's add our web search code. This is gonna be the easiest tool you've ever written in your life, so let's do that. I'm going to check out to lesson 7. We are just going to go to our tools. We're gonna make a new tool. We're gonna call it web search. It's gonna be super simple because we're not gonna make it at all because it's already made, but we're just making sure it fits within our standard of how we do our tool composition. So we don't have to change any other code. So we'll just say export const web search equals, in this case, it'll just be openai.tools.web search. And if you do this, you can see all the tools that we get from OpenAI on their service. So we get code interpreter. Like I said, you can pass it a string for it to execute in Python and JavaScript, maybe other languages. File search is as if you have files on OpenAI because you can attach files to an LLM and they store them for you. This allows you to search it. Image generation, if you're into Dolly, I guess, it's not good. Local shell. This one's kind of cool because they don't run the shell commands, but they give you the commands that you can then run, which is kind of cool. And we will be doing a shell tool, but we won't be doing it this way. Web search, that's what we're using. And then web search preview is just like their experiment version of web search, the one that they keep messing around with. So we will do web search and we will give it no arguments. That's it. And then we go to our tools file and we want to go ahead and import that and add that in here. So we will say import web search from web search, add it to our tools, web search, and then let's just export web search. You might see some other tools in there in the code. Those are other ones that we will write after this. Oops. There we go. Cool. Now that we got the web search, we should just be able to use it right now and give it a try. Let's build this. Cool. I'm gonna install it again, which I don't think I need to do this, the install every time, but I just do it. And then I'm just gonna ask it, do you have the ability to search the web? See what it says. Yes, I can search the web using a browsing tool. Okay, so let's ask it something. Okay, who won the F1 Vegas Grand Prix in 2025? Please only use one web search, no more. So I don't want this thing to break. Hopefully it listens to me. It's thinking, it's doing a web search. Please only do one. I think it only did one. I think by now it would have like shot off like 20 of them already. There we go. Yeah, Max Verstappen, he did win. It's pretty accurate. So, and they actually give you, again, maybe they give you the sources so you can click on this. And there we go. Took me to the source where it got it from. It's pretty impressive. Now your agent is no longer bound by its training date cutoff. You can make it live, right? You can ground it. So pretty powerful, right? Like this thing can do anything now. Like give it the web. Yeah, trust me, I know.